Hello, we are the audience for Brandon Van Rosendale's speech.
The movie Interstellar that recently came out was based a lot on the theory of relativity, which is broken down into two groups, special relativity and general relativity. So today I'm going to talk to you about some of the basic fundamentals of the theory of relativity. Special relativity is broken down into 5 different groups: simultaneity, velocities, time dilations, the Lorentz contraction theorem, and the twin paradox. Now, some of the basic ideas of special relativity are that you can't go faster than the speed of light because nothing can go faster than the speed of light. And the reason that the theory of relativity came around was way back in Einstein's day when he was coming up with this, is they realized once you approach the speed of light, Newton's second laws of motion don't apply to the things in motion. And special relativity mainly deals with objects in an inertial frame of reference, which is really velocities and time and things of that nature. So when you're reaching the speed of light, which is 3.08 times 10 to the 8th meters per second, a lot of things can happen. Like the length at which a third party would be watching you, the length would seem to contract of your spaceship, or I guess whatever you're flying in or driving in, and the time, say you have a clock in your spaceship, the time would seem to slow down from a third party's perspective. But for you on the spaceship, it would seem to be staying at a constant speed. And as you are traveling at a velocity in the spaceship, say you throw a ball out of that spaceship, it can't go faster than the speed of light. It will just go with the speed of light. There's something called the twin paradox, stating that if a spaceship travels off into another dimension, it will go a velocity and the time will change, but time on Earth will keep going the same as it always does. And as you come back, the time from the spaceship and the time on Earth will be different. So then the person on the spaceship and the person on Earth will supposedly, one will be younger than the other. And in Interstellar, they state that the person in the rocket ship is going to be younger than the person on Earth. But Albert Einstein states that this is how it's going to be. But some people argue with this and they go back and forth. General relativity deals a lot with forces of gravity and stuff like that. The space-time continuum, it works a lot with that. The space-time continuum is a fabric that works without the universe. It's space and time interwoven together. The sun, the earth, they all interact on it together. It's basically like the earth pushing down on a trampoline, and that's how gravity works. You know, Newton thought that the earth was pushing in or pulling stuff in on it, but basically things are pulled in by the space-time continuum and pushed towards Earth. And then black holes are a part of general relativity. Black holes are just a big, giant, I guess they're not even that big, but they are a dense ball that interact with so much force that they have probably about 100 times more gravity than our sun, and it's just magnificent. With some of these advancements in physics, if we wouldn't have had them, I mean, we wouldn't know half of the stuff that we know today. And I guess we just owe Albert Einstein to that. So thank you, Albert Einstein.